Okay, this tutorial is going to quickly cover the idea of alloys. So let's get into it. Now to start off with, there is a pretty neat little video clip. It's actually on another YouTube channel, so I'll put that in the playlist so you can check that out in amongst my videos. However, it goes into a lot more detail than you need, so I recommend just watching the first wee little bit, just about the first third. So this is a little video clip there. Alright guys, what is an alloy? An alloy is just a mixture of two or more materials. More specifically, it's a mixture of generally two metals, although there is one exception where it's actually a metal and a non-metal. So this first one here just shows how when you add a small amount of another, say metal, to the base metal, sometimes it can substitute some of the spots, so you get these spots within it, or sometimes they can fit in between the metal atoms. And what happens is at the atomic level, basically the metal that's been added to the base metal will change the properties slightly of the material as a whole. So the reason we often make alloys is basically they add strength, or they reduce the corrosion, they prevent the metal from rusting, and so it is really a case of sometimes combining two metals. The interaction at the atomic level means that you get new properties. So some alloys are actually stronger than both of the metals from which they're formed. However, sometimes it is just a case of maybe you've got two metals and one's nice and cheap and strong, like steel, and the other one maybe it doesn't rust, like chromium, and so when you combine them you kind of get the best of both worlds. So an alloy, like we said, the advantage of alloys is that a lot of alloys are more durable and less prone to corrosion, whereas a lot of pure metals are often more malleable, more ductile, so they're softer and easier to beat into a shape or stretch into wires. So they have their pros and cons, but a lot of alloys, especially for structural things and for a whole lot of other purposes, really do have their advantages. So let's have a look at a few examples. Brass is usually a mixture of copper and zinc. Other metals are often added in small amounts as well. So brass is sort of a gold color, it's got good acoustics, it's smooth, it's resistant to corrosion, and it's often used in things like pipes or instruments. I think your brass band is your or your brass instruments. Those instruments are largely made out of brass. Coins and decoration, and so brass is often sometimes used I guess even as a substitute where gold just we can't afford gold, so maybe light fittings, things like that, might be made out of brass. A lot of taps are sometimes made out of brass, so it's quite resistant to corrosion. With the water flowing through it, it won't rust. Bronze, so known since the Bronze Age, one of the first probably alloys, or the earliest alloys to be used, usually copper and tin, but again sometimes small amounts of other metals, and sometimes this is considered a type of brass. It's reddish in color. I don't know if I'd really consider it reddish, but it is sort of a really sort of slightly more gold color. It definitely has that slight reddish tone to it, like copper does. It's durable, and it's resistant to corrosion. So bronze is often at least a big part of what they make the bronze medals out of at the Olympics. But it has a whole bunch of other uses too, and it's probably the copper that's giving it that sort of really brownish color. Steel. So steel is actually an alloy. It's mainly iron, but they've actually added a small amount of carbon, and this is our exception. This is the one alloy that isn't a mixture of metals, because carbon technically is not a metal. So carbon technically is a non-metal, but actually is right on the boundary, and it can actually be considered a metalloid. So that means it's got properties in between metals and non-metals, and that's why it can be mixed in with iron to form an alloy. So adding the carbon just increases the strength or the durability of the alloy slightly, but other things can be added to steel as well to essentially alter its properties too. So stainless steel basically they add a small amount of chromium, and that chromium prevents the steel from rusting. So the biggest downside to steel is that steel rusts. Steel is one of the cheapest metals, and it's also a very strong metal, so that's great, but it does corrode, it rusts, and it rusts fairly rapidly. It's fairly prone to that. So adding a bit of chromium turns it into stainless steel, and means that it's much more resistant to that to rusting. Adding other things it can also change its properties in other ways too. Amalgam, so this is stuff that's used in your fillings. It's actually got a bit of mercury and silver and tin in it, and so when mercury is added to these other metals, it actually hardens. So it's a material, I guess, a metal that's fairly soft that can be used to make these fillings, but it's strong enough, and it's resistant to corrosion too. It's also relatively non-toxic. Now, mercury on its own can be toxic, but in combination with these other metals, it's no longer toxic. Duralumin is an alloy of aluminium with copper, magnesium, and manganese, and so it's just a durable, strong, but very light material. So something that can be used for aircrafts. Gold. Now I thought this one was really interesting because you've probably heard of rose gold and white gold and things like that. So 24 karat gold is pure gold, and 18 karat gold is actually 75% gold, all the way down to sort of like 12 karat gold is only 50% gold. So they actually add other metals in there to fill in the rest of the space. Now if you add a little bit of copper, that gets you sort of red gold, or adding a bit of copper and silver makes it your rose gold. White gold, they add platinum, and that's why white gold is actually more expensive than gold, than regular gold, because platinum is actually a more expensive metal than gold. So because to get white gold you have to add a little bit of platinum to it, it's obviously going to increase the cost. Sterling silver. So this is copper is an alloying agent to silver, and so pure silver is far too soft to make a lot of materials out of. So cutlery and things like that, if it was pure silver, the cutlery would just simply be too soft. You'd bend it and potentially break it. So copper just gives it a bit of strength. I suppose adding a bit of copper in there makes your silver also stretch a bit further, so maybe it makes it a bit cheaper. But it is a way that you get the strength of the copper, but you get that look of silver. It looks a lot like silver, and it's a lot less prone to corrosion, because silver is one that really doesn't corrode. So you get nice shiny silver serveware and cutlery that is that's still hard enough or strong enough to actually use. So that's the examples I've got there. I'm sure there are others. I don't think you need to know every single example there. Just the main idea that alloys are basically mixtures of metals, or technically it can actually be a mixture and a non-metal. Although that's very rare. It's not really. Most alloys are mixtures of metals, and the only really example of mixing with a non-metal is in steel, where iron has a little bit of carbon added. And I think the only reason that's really possible is that carbon is right on the boundary. It's actually a metalloid anyway. So guys, just be aware that you can mix these things, and that you get sometimes new properties or a mixture of the two properties. And maybe remember an example or two, but you definitely don't need to know all of them. Cool, I hope that helped, and that's it.